Chapter 1 Review. Conceptual questions. 1.1. Temperature and thermal equilibrium. 1. What does it mean to say that two systems are in thermal equilibrium? 2. Give an example in which A has some kind of non-thermal equilibrium relationship with B, and B has the same relationship with C, but A does not have that relationship with C. 1.2. Thermometers and temperature scales. 3. If a thermometer is allowed to come to equilibrium with the air, and a glass of water is not in equilibrium with the air, what will happen to the thermometer reading when it is placed in the water? 4. Give an example of a physical property that varies with temperature and describe how it is used to measure temperature. 1.3. Thermal expansion. 5. Pouring cold water into hot glass or ceramic cookware can easily break it. What causes the breaking? Explain why Pyrex, a glass with a small coefficient of linear expansion, is less susceptible. 6. One method of getting a tight fit, say of a metal peg in a hole in a metal block, is to manufacture the peg slightly larger than the hole. The peg is then inserted when at a different temperature than the block. Should the block be hotter or colder than the peg during insertion? Explain your answer. 7. Does it really help to run hot water over a tight metal lid on a glass jar before trying to open it? Explain your answer. 8. When a cold alcohol thermometer is placed in a hot liquid, the column of alcohol goes down slightly before going up. Explain why. 9. Calculate the length of a 1 meter rod of a material with thermal expansion coefficient alpha, when the temperature is raised from 300 K to 600 K. Taking your answer as the new initial length, find the length after the rod is cooled back down to 300 K. Is your answer 1 meter? Should it be? How can you account for the result you got? 10. Noting the large stresses that can be caused by thermal expansion, an amateur weapon inventor decides to use it to make a new kind of gun. He plans to jam a bullet against an aluminum rod inside a closed inver tube. When he heats the tube, the rod will expand more than the tube, and a very strong force will build up. Then, by a method yet to be determined, he will open the tube in a split second and let the force of the rod launch the bullet at very high speed. What is he overlooking? 1.4. Heat transfer, specific heat, and calorimetry. 11. How is heat transfer related to temperature? 12. Describe a situation in which heat transfer occurs. 13. When heat transfers into a system, is the energy stored as heat? Explain briefly. 14. The brakes in a car increase in temperature by delta T when bringing the car to rest from a speed versus. How much greater would delta T be if the car initially had twice the speed? You may assume the car stops fast enough that no heat transfers out of the brakes. 1.5. Phase changes. 15. A pressure cooker contains water and steam in equilibrium at a pressure greater than atmospheric pressure. How does this greater pressure increase cooking speed? 16. As shown below, which is the phase diagram for carbon dioxide? What is the vapor pressure of solid carbon dioxide, dry ice, at negative 78.5 degrees Celsius? Note that the axes in the figure are nonlinear and the graph is not to scale. Figure. Temperature T, degrees Celsius. Pressure P, atm. CO2. Triple point. Critical point. 17. Can carbon dioxide be liquefied at room temperature, 20 degrees Celsius? If so, how? If not, why not? See the phase diagram in the preceding problem. 18. What is the distinction between gas and vapor? 19. Heat transfer can cause temperature and phase changes. What else can cause these changes? 20. How does the latent heat of fusion of water help slow the decrease of air temperatures, perhaps preventing temperatures from falling significantly below 0 degrees Celsius, in the vicinity of large bodies of water? 21. What is the temperature of ice right after it is formed by freezing water? 22. If you place 0 degrees Celsius ice into 0 degrees Celsius water in an insulated container, what will the net result be? Will there be less ice and more liquid water, or more ice and less liquid water, or will the amounts stay the same? 23. What effect does condensation on a glass of ice water have on the rate at which the ice melts? Will the condensation speed up the melting process or slow it down? 24. In Miami, Florida, which has a very humid climate and numerous bodies of water nearby, it is unusual for temperatures to rise above about 38 degrees Celsius, 100 degrees Fahrenheit. In the desert climate of Phoenix, Arizona, however, temperatures rise above that almost every day in July and August. Explain how the evaporation of water helps limit high temperatures in humid climates. 25. In winter, it is often warmer in San Francisco than in Sacramento, 150 km inland. In summer, it is nearly always hotter in Sacramento. Explain how the bodies of water surrounding San Francisco moderate its extreme temperatures. 26. Freeze-dried foods have been dehydrated in a vacuum. During the process, the food freezes and must be heated to facilitate dehydration. Explain both how the vacuum speeds up dehydration and why the food freezes as a result. 27. In a physics classroom demonstration, an instructor inflates a balloon by mouth, and then cools it in liquid nitrogen. When cold, the shrunken balloon has a small amount of light blue liquid in it, as well as some snow-like crystals. As it warms up, the liquid boils, and part of the crystals sublime, with some crystals lingering for a while and then producing a liquid. Identify the blue liquid and the two solids in the cold balloon. Justify your identifications using data from Table 1.4. 1.6. Mechanisms of heat transfer. 28. What are the main methods of heat transfer from the hot core of Earth to its surface? From Earth's surface to outer space? 29. When our bodies get too warm, they respond by sweating and increasing blood circulation to the surface to transfer thermal energy away from the core. What effect will those processes have on a person in a 40.0 degrees Celsius hot tub? 30. Shown below is a cutaway drawing of a thermos bottle, also known as a Dewar flask, which is a device designed specifically to slow down all forms of heat transfer. Explain the functions of the various parts, such as the vacuum, the silvering of the walls, the thin-walled long glass neck, the rubber support, the air layer, and the stopper. Figure. Container. Rubber support. Air layer. Spring centering device. Glass walls with silvered surfaces. Vacuum. Hot or cold liquid. 31. Some electric stoves have a flat ceramic surface with heating elements hidden beneath. A pot placed over a heating element will be heated, while the surface only a few centimeters away is safe to touch. Why is ceramic, with a conductivity less than that of a metal, but greater than that of a good insulator, an ideal choice for the stove top? 32. Loose-fitting white clothing covering most of the body, shown below, is ideal for desert dwellers, both in the hot sun and during cold evenings. Explain how such clothing is advantageous during both day and night. 33. One way to make a fireplace more energy efficient is to have room air circulate around the outside of the firebox and back into the room. Detail the methods of heat transfer involved. 34. On cold, clear nights horses will sleep under the cover of large trees. How does this help them keep warm? 35. When watching a circus during the day in a large, dark-colored tent, you sense significant heat transfer from the tent. Explain why this occurs. 36. Satellites designed to observe the radiation from cold, 3K, dark space have sensors that are shaded from the sun, Earth, and the moon and are cooled to very low temperatures. Why must the sensors be at low temperature? 37. Why are thermometers that are used in weather stations shielded from the sunshine? What does a thermometer measure if it is shielded from the sunshine? What does it measure if it is not? 38. Putting a lid on a boiling pot greatly reduces the heat transfer necessary to keep it boiling. Explain why. 39. Your house will be empty for a while in cold weather, and you want to save energy and money. Should you turn the thermostat down to the lowest level that will protect the house from damage such as freezing pipes, or leave it at the normal temperature? If you don't like coming back to a cold house, imagine that a timer controls the heating system so the house will be warm when you get back. Explain your answer. 40. You pour coffee into an unlidded cup, intending to drink it 5 minutes later. You can add cream when you pour the cup or right before you drink it. The cream is at the same temperature either way. Assume that the cream and coffee come into thermal equilibrium with each other very quickly. Which way will give you hotter coffee? What feature of this question is different from the previous one? 41. Broiling is a method of cooking by radiation, which produces somewhat different results from cooking by conduction or convection. A gas flame or electric heating element produces a very high temperature close to the food and above it. Why is radiation the dominant heat transfer method in this situation? 42. On a cold winter morning, why does the metal of a bike feel colder than the wood of a porch?